So we've seen here that we can use that dilution ratio to adjust our percents, and we can use our desired percents to figure out what dilution we want. So let's say that we have let's just go with 36 milliliters of 64% solution. We want to dilute it to, let's go 16%. How much sterile water do we need to add? So the first thing we need to find our dilution. And the dilution we're going to use here is, remember, the ratio of the new percent to the old percent. So in this case, that ratio is going to be what? 16 over 64. Of course, the percents cancel out, and that reduces to 1/4. So we have a 1 in 4 dilution. Now, if we're looking back at that as a dilution, remember the 1 is the concentrate, and the 4 is the total solution. We know how much concentrate we're going to use. We're going to use the 36 milliliters. But we're not looking for the total solution here. We're looking for the amount of NS, of sterile water. So we can go ahead and find this total and subtract. Or I can adjust this ratio to be a 1 in 3 ratio. So now it's describing the concentrate and the water. So on the other side, I put my 36 milliliters, and I can cross multiply and divide. 3 times 36 divided by 1 is 108 milliliters. Does that make sense? Let's say we are going to add 120 milliliters of NS to 30 milliliters of 80% solution. Find that new concentration, that new percent. So here we're not given the 2%, we're given the ingredients. So let's create our dilution again. Remember, dilution is concentrate or serum over total. So what goes on top for a concentrate? 30 milliliters. What's going to go on bottom for a total? 150. It's going to be the 30 milliliters plus the 120. So that gives us 30 over 150, which reduces to a 1 in 5 dilution. So now that we have that 1 in 5 dilution, we can use that 1 in 5 as the ratio of our percents. Where's the 80% going to go? On bottom, right? That's the larger one. After it's diluted, it's going to be a smaller percent. So we cross multiply and divide. 1 times 80 divided by 5. The new solution will be 16%. Find the new percent, the new concentration, after a 42% solution goes through a 3 and 7 dilution. So here we don't have any amounts. We're just asked to find the new percent. But we have the dilution is 3 and 7. And that dilution is going to be directly related to our ratio of percents. Where's the 42 go? Top or bottom? Bottom. And we'll cross multiply. 3 times 42% divided by 7 is what? 18% is the new solution? So in your notes, I'm going to have you try this one. Find the new percent when 240 milliliters of normal saline is added to 40 milliliters of 70% solution. So in your notes, try to find that new percent. So again, to do this one, we need to have our ratio of concentrate to total. How much concentrate did we use here? (40 milliliters of the 70% solution. What's our total volume? Here are 40 milliliters plus the 240 milliliters of NS. Which gives us 40 over 280, which reduces to a 1 in 7 dilution. Once we have that as a 1 in 7 dilution, we can set up our proportion. Where's the 70% going to go? On bottom. So we don't really need to cross multiply and divide, but we'll find that that is 10% if we do it. Any questions? Okay. Another one for your notes. How much NS to add to 60 milliliters of 24% solution in order to reduce it to 4% solution. Give you a couple minutes for So in a problem like this, we figure out our dilution again, but we're given the percents rather than the amounts, the volumes. So we can use our percents to find the dilution. Our new percent is going to be 4% over the old percent of 24%, which is going to reduce to a 1 in 8, or not 1 in 8, 1 in 6 dilution. So we've got a 1 in 6 dilution. Remember, the 1 is the concentrate. That's going to be the 24% in this case. The 6 is the total. We want to know how much neutral solution or normal saline to add to that. So I'm going to create the ratio of 1 to 5. The 1 is still our 24%, but the 5 now represents our water. 6 minus 1 gives us the 5. So now we have 60 milliliters of the 24% of the concentrate. We cross, multiply, and divide. 5 times 60 divided by 1 is 300 milliliters. What do you think? Okay, so there is a different way of adjusting these concentrations. Because it happens often enough, we use this relationship where we had the new concentration over the old concentration is related to our volume. It's related to our dilution in this case. Our dilution, however, relates our volume. The old concentration must have a smaller volume than the new concentration, correct? So it is the first volume that goes on top over the new volume. This is what we call an inverse relationship. In Unit 4, we'll actually talk about direct variation and inverse variation. In an inverse relationship, you can see the proportions don't match up. The ratios don't match up. Here it's the new over the old. Over here it's the old over the new. It becomes flipped. The reason for that is if I'm assuming again that the amount of active ingredient or the amount of medication does not change from the before to the after. Remember, the amount of active ingredient before is the concentration times its volume. That has to equal the new concentration times the new volume. And if the concentration is to be reduced, that volume has to go up so that we stay at the same total amount. This formula here, by the way, that I just wrote out, is the concentration adjustment formula used in the book. And that actually comes from these dilutions. And what it is saying is simply that if I know the concentration and volume before I dilute something, I can find the volume or the concentration after dilution. So I might say using 150 milliliters of 18% solution, how much 12% solution can be created? Now we could do this with our dilutions before where we just had 12% over 18%, which reduces, giving us a 2 in 3 dilution. And if we have a 2 in 3 dilution, the old volume of 150 would be the smaller number, right? That is the concentrated volume over whatever our new volume is. Cross, multiply, and divide. 3 times 150 divided by 2 is 225 milliliters. But it's simpler, rather than going through that two-step process, sometimes even more than 2 steps with dilutions, to just use this formula here. We know that before we had a concentration of 18%. 0.18. I don't even have to write it as 0.18. I can leave it as 18%. And we had a volume of 150 milliliters. After our concentration changes to 12%, And we need to know the new volume, V2. Now, mathematically, that 2 there does nothing. That's just indicating that's the new volume instead of the old volume. To solve this, I'm going to multiply my 18 times 150, which is, what, 2,700? Equals 12 times V2. And then I'm going to divide by 12. 2,700 divided by 12 is 225. So that new volume is 225 milliliters. Or we could use it in the other direction. Let's say we have 30 milliliters of 64% solution. It is diluted to a volume of, let's see here. 240 milliliters. Find the new concentration. Find the new percent. So we have our original concentration and percent. Percent times volume. So 64% times 30 milliliters. Now on the other side, we're looking for the new percent, the new concentration. So that's C2 that we're looking for, times our new volume is 240. So to solve, we're going to do 64 times 30, which is 1,920, and divide by 240. $1,920 divided by 240 is 8. So that new concentration is 8, or 8%. Does that make sense? It's just a lot shorter than going through the dilutions. So now we're going to ask how much NS is needed to dilute 200 milliliters of 32% solution to 8%. Now again, we did a problem like this using our dilutions. We're going to use it with the concentration formula, concentration adjustment formula. So we have 32% and 200 milliliters described the before. So it's 32 times 200 equals, we know 8% afterwards times our new volume. So 32 times 200 is 6,400. We'll divide by 8. So 800 is our new volume. Is that what we're looking for? No, we don't want to know the new volume. We want to know how much saline or sterile water was added here. To figure that out, it is simply subtracting the 800 milliliters of the new solution minus the 200 milliliters of the old solution. The difference has to be made up with neutral solution, because we did not add anything medicinal to it. Any questions? Well, I have time for you guys to try one. 600 milliliters of NS is added to 120 milliliters of 84% solution. Find the new concentration, the new percent. I'll give you a couple minutes to try. Put the formula back up there again, just to remind us of it. So do we know both of the befores? Usually we do, right? There's got to be one that we know both the volume and the percent for. So we'll just count that as the before. So we had 84% times 120 milliliters. On the other side, what do we know? We're asked to find the percent, so we know C2 is what we're going to be looking for, the concentration. What's the volume? A lot of people want to put in 600. It's not 600. Why not? That's just the saline. It is added to 120. So what has to go in here is 600 milliliters plus 120 milliliters to get the total volume afterwards. So I'm going to combine here the 84 times 12. It's 1,008. On the other side over here, we have 600 plus 120 is 720. So now to solve for C, we're going to divide by 720. I'm wrong. So 14% is what it comes out to be, right? I just made a decimal. I missed a 0. 84 times 120, so 84 times 12. So this should be 10,080 there, not 1,008. So you divide by 720, it is 14%. How many of you got 14%? Okay, let's look at another one. How much normal saline to add to a 100 milliliters of 20% solution to reduce it to 4%. Maybe try doing that one. So we start off with, we know we have 20% times 100 milliliters. That's going to equal 4% times whatever our new volume is. So 20 times 100 is 2,000. It's 4 times V2. And we will divide by 4. V2 is 500 milliliters. Is that our answer? No, what do we have to do yet? You got it. 500 milliliters minus the 100 milliliters that we had before gives us a difference of 400 milliliters. The saline has to be used to make up the difference. Find the new percent if 80 milliliters of 36% solution are diluted to a volume of 200 milliliters. So I'll give you a minute to find that one. This one's actually pretty straightforward. That's why it can be confusing. We have the original percent, 36% times 80 milliliters. And that's going to equal our new percent times the 200 milliliters is that new volume. So 36 times 80, 2880 equals C times 200. And we divide by 200. 14.4% is our new percent. How are you guys feeling about all this? Not too bad?
Why did you add 80?
What's that?
Why did you add the additional 80 milliliters?
Because it's not, the 200 was not just saline, it was the volume after it was diluted.
Oh.
So that already included the original 80. That's why I said this one's very straightforward. That's why it's confusing. Because we didn't have to do that. Every other problem we had to worry about adding that in. This one, it was already given, you add it in. Okay, well, I think I'm going to cut it off there for the day. I'm not feeling that well, and I can feel myself starting to talk in circles a little bit. So rather than confuse you guys, I'm going to stop there. So some homework to practice is the dilutions on page 130 to 132. 1 through 37, the odds. Also page 134, 1 through 11, the odds. That's using dilutions to change the percent. And it's took a little bit simpler approach. All they're looking at is that the dilution ratio is equal to the ratio of the percents. And then this concentration adjustment formula on page 138, 1 through 17, the odds. Anybody have any questions before we hang it up? Okay, well, you guys have a great weekend, and we'll see you next week. Oh, the tests handed back. I got to hand them back here. Everybody else have your tests back at the other locations?
No.
Okay, they should have been emailed back to you. I emailed it back as an attachment probably yesterday. So if you check your email, if you didn't get it, send me an email, and then I can just respond with a copy of your test. I will say this, I grade them with the ink, so if you open them at home, you may not be able to see the ink. So if that's the case, you can either access it from one of WITC's computers, so they have the ink program on it, or just send me a message, and I can send back to you telling you which problems you had wrong. But if you didn't get it in your email, send me a message, and I will get it back to you.